dive into inverses, exponents, and logarithms. So we're going to be able to decide if a function is one-to-one. If it's one-to-one, then we're going to find the inverse. We'll use the horizontal line test to determine if a function is one-to-one. We're given two graphs. And we'll be able to find the equation of the inverse and then graph them. So if I want to determine if a function is one-to-one, each x value has to correspond to only one y value. And each y value can only correspond to one x value. So this would not be one-to-one because 2 and 3 both correspond to 7. However, in this one, each number has a unique partner, so it is going to be one-to-one. The inverse of a one-to-one function is written as f with the exponent of -1. We just read that as the inverse of f. And the inverse is the set of all ordered pairs where we're switching the order of x and y. So instead of being x comma y, it's y comma x. So for this reason, the domain of the original function becomes the range of the inverse, and the range of the original function becomes the domain of the inverse. So for this one, we're going to look at each coordinate to determine if it is one-to-one, and if it is, we're going to find its inverse. By looking at all the values, you can see that each x value only corresponds to one y value, and vice versa. So I know this function is one-to-one, therefore I can find the inverse. To find the inverse, all I'm going to do is switch the x and the y values of the coordinates. Here, I'm looking and it's not one-to-one because both 0 and 1 correspond to 3. So it's not one-to-one and I cannot find the inverse. Now in the lab, I want you guys to be very careful because the lab will allow you to say, oh yes, there's an inverse, and then you input the inverse, and that's when it tells you you're wrong. And a lot of the time students get stuck because they're like, well, I switched the x and the y, I switched the x and the y, the lab's wrong. No, you didn't check to see if it was one-to-one first. So make sure you're checking if it's one-to-one, and if it's not, you have to select there's not an inverse. So if we're given two images, there's a quick way to check this, and we call it the horizontal line test. Remember the vertical line test that told us if something was a function? This is very similar, but we're going to draw a horizontal line. And if the horizontal line crosses more than once, then it's not a one-to-one function, which means it does not have an inverse. So parabolas do not have inverses. But a square root function does, because it only touches once. With an equation, we have to take it beyond just interchanging our x and our y's, because when we graph equations, we do them in y equals form. So what we're going to do is we're going to switch the x and the y, and then we're going to solve it back for y. Once we get there, we want to replace y with the inverse of f of x, because we want to notate, hey, this is an inverse, not an original equation, because our inverse is going to rely on some information from the original function. So here, first we're checking is it one-to-one. You can do that by looking at the graph. You can use Desmos.com to quickly graph it. You'll see that it's a line and it does pass the horizontal line test. Once you know that piece of information, we know it's one-to-one and we can switch the x and the y. Now to solve this back for y, I'm going to add 4 to both sides. Then I'm going to divide everybody by 3. I'm going to replace y with the inverse of x. And look at these two values. It's almost like we did everything the opposite, right? Instead of subtraction, it's addition. And instead of multiplication, it's division. You're going to notice that pattern as you go. As we get into some of the more complex functions, it might not be this easy to tell, but that is the general idea. If I have x cubed plus 1, I'm going to graph it on Desmos.com, and I see that it does pass the horizontal line test. At which point, I'm going to switch the x and the y and solve it for y. I'm going to subtract 1 from both sides. Remember, to solve for something when you have a cubed exponent, you take the cube root of both sides. And then I'm going to replace that y with the inverse notation. If I wanted to do x minus 3 squared, that is a parabola which does not pass the one-to-one horizontal line test. So that's it. I can't take it any further. I can't find an inverse. For this one, you're going to need to go ahead and graph it. It does pass the test. I'm going to replace that f of x with a y so it's easier, and I'm going to swap them. Once I complete that swap there, I'm going to go ahead and get rid of the denominator of y plus 2 by multiplying both sides by y plus 2. Then I'm going to distribute the x, and I'm going to get all of my y's on the same side by subtracting that y over, and I'm going to factor the y value out. This is the most common problem in the lab that students get stuck on, because you have to factor that y out and then divide. So let me go back through that one more time. So follow with me. I switch the x and the y's. I multiply both sides by y plus 2 to get rid of the fraction. I distribute the x, and then I get all of my y values on the left. I'm going to factor the y out and divide both sides by x minus 1. So that my final answer is negative 2x minus 4, and I have to quantify that as x can't be 1, because if x is 1, I get undefined. So in the lab, be very mindful of that. If I want to graph the inverse from the graph of the original function, you can select several different ordered pairs and then switch the x and the y's to plot the new points. Then we can connect them. So if I take each one of these points and I switch the x and the y, it would generate this graph. What do you notice about this graph? If I folded my paper diagonally across the origin, they would be a complete mirror of one another. This is a great way to check your work in the lab. If you're not sure if you correctly found the inverse, if you graph both equations in Desmos.com, you should see the same symmetry each time. They should be symmetric about that diagonal line.